All right, guys, in this video, we're going to be talking about saturation. That word's in the top left corner of your screen, and so make sure you're going to take some notes today, so make sure you take notes with me. In the last video, we were talking about dissolving. And so dissolving is a different process than what we really understand it to be, so I want to make sure we understand that. But dissolving leads to saturation. Okay, so let me give you an example. When I was first teaching this many years ago, I decided, I wonder what kids think dissolving is. So my daughter was like in third grade, and at dinner that night, I asked her, I said, hey, what is dissolving? And she said, it's when you take like water and you put like sugar in it and you mix it up until it disappears. And I thought for a third grader, that's pretty good. So I come to school the next day and I asked the class, my sophomore class, hey, can somebody tell me what dissolving is? And somebody raised their hand and said, yeah, it's when you take like a liquid and you pour something in it and you mix it up until it disappears. And I thought, that's the same example my third grader said. And I thought, wow, maybe my third grader is really smart. And she is. But the idea was we really don't know what dissolving is. We've just seen it before. So in the last video, you were talking about dissolving, how particles break into small enough pieces that they're not naked to the eye. I mean, they're visible to the naked eye. You can't see them anymore. And so there are three ways to make things dissolve faster, and you got that from that video. Well, as you start dissolving things into one another, you can reach what is called saturation. And saturation is a very important topic, so make sure you're ready to take notes with me. Now, in this video, there's no sound. That's why I'm doing a screen castify, so I'm going to explain as we go. There are three kinds of saturation. Okay, and we're going to talk about unsaturated, saturated, and supersaturated. Now, if you want to go ahead and write these words down, you'll want to write unsaturated, maybe skip 2 lines, saturated, skip 2 lines, and then supersaturated. If I get ahead of you, you can just pause the video, make sure and get that. We're going to talk about them each at a time. Okay, so let's talk about unsaturated. Here's what they're going to use an example here from the chemistry lab. In this example, they're going to take 15 grams of sodium acetate trihydrate in 50 milliliters of water. Now I want to point out something real quick. We've never seen that before. So let's talk about it real quick. 15 grams of sodium acetate. Well, I know that sodium is Na and it's +1 on the periodic table. Acetate, we memorized that. C2H3O2, -1. Got it. What does trihydrate mean? Well, tri means 3. Hydra means water. It's actually a molecule. We don't have a lot of these, but it's a molecule that has water stuck to it. So think of it like this. There is a molecule, and then it's got water, water, water stuck on 3 sides. Now, the way they write it out looks something like this. If you look in the corner here, sodium is Na, acetate C2H3O2 dot 3 waters. Okay? That dot 3 waters means it's a hydrate. Now, maybe you've seen one of these and maybe you haven't. Girls may have seen one of these hydrates before. They will sell at some of the art places. You can take these little spheres that are water filled and you can put them inside of a vase with water, and they've got water in them and they'll keep your flower alive longer. They're hydrates. Where all of us have seen it is when you buy a purse or you buy a new pair of shoes and it has that little packet in it and it says do not eat. Have you ever read the packet before? Its job is it's dehydrated. It's going to absorb water out of the air and it's going to become a hydrate. It's going to steal water out of the air so that your leather materials or your nice shoes don't have moisture from the air, so it still looks brand new. Okay? And so inside that packet is that kind of substance. And if one's ever broken off, you don't want to eat it. It's dangerous for you. But it's just like little tiny crystals. And so what they're going to do here is they're going to take that 15 grams of sodium acetate hydrate and they're going to mix it into 50 milliliters of water. And here it is. They dump it in there and mix, 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 mix. Quick question. Did it all dissolve? Yeah, why? Can't see it anymore. There's nothing sitting on the bottom. That is an unsaturated solution. Make sure you get that definition right there. Solution can dissolve more solute. It means you could still dissolve more in there. That all dissolved in, you could probably dissolve more. So let's take one that you and I would do. And let's say that you go to eat dinner at your grandma's house and she has unsweet tea, but you don't like unsweet tea. So you may take 2 packets of sugar or sweetener and mix it in really good until it dissolves. That's unsaturated. because saturated means completely full. Now you could probably put more than that, but the 2 packets is probably enough. If it's sweetener, it might be 1 packet, but it has the sweetness you need. Okay, that's unsaturated. Now the next term, they're going to use that same compound, but they're going to do something different with it. This time they're going to take a saturated solution. Now maybe you've heard this word before. We hear the word saturated when we talk about fats that are in our diet, unsaturated fats and saturated fats. Okay, one of them's good for you, one of them's not good for you. The saturated fats are not good for you, and it's because it's hard for your body to break them down. And so when you go to break them down, if you don't break them down all the way, what will happen is they can collect in your bloodstream and stick to the end of your blood vessel, inside your blood vessels, and over time it makes that blood vessel get thinner and thinner so that blood doesn't go through there very well, and you may in later life have a problem with it. Okay? And so you want to try to eat more unsaturated fats than saturated fats. Maybe you've even heard the weatherman talk about the clouds are saturated. What does that mean? They're full of water, which means it's probably going to rain. If you were to take like a shirt and just push it into a sink full of water, when you pull that shirt out and it's dripping, that is saturated. Here's what it looks like chemically. Instead of 15 grams of that sodium acetate trihydrate, this time they're going to put 62.5 grams of that sodium acetate trihydrate in the same amount of water. Watch what happens. Pour it in there, mix, 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 mix. Question, did it all dissolve? No, I see the stuff on the bottom right there. It's saturated. It's saturated. That water cannot hold any more of that chemical. Solution cannot dissolve more solute. It's full. Okay, it's full. Now, if you added more water, yeah, then you could add more of that compound. Okay, so the same thing would be true. I know people, let's say, for example, you go to Chick-fil-A, they have pretty sweet tea. And I've known people along the way that they take that sweet tea and they add more sugar or sweetener to make it like super sweet. Oh my gosh, it's so, until sugar falls to the bottom. When it starts falling to the bottom, it won't hold anymore. Now, you learned in the last video, you could make it hold more by doing a couple of things. You could add more tea and then mix it up. That would work. Or you could heat it up. Hot tea will dissolve more sugar than cold tea. Everybody knows that. Okay, but in this case right here, 62.5 grams of sodium acetate trihydrate is all that dissolves. It's saturated. Then there's this word we're not used to seeing. In this case, it's called supersaturated. Now, supersaturated has a very different meaning, and so I want to explain it to you. Supersaturated, okay? Supersaturated. Here's what happens. You've probably seen it in a couple of different things. Here's a good example. Rock candy on a stick. Rock candy on a stick is supersaturated. Okay, so here's what they do. They take a pot of water and you heat it until it's boiling. Okay, so when the water's boiling, it can hold the most sugar possible. And you dump all this sugar in there and you mix it in really good until it's all dissolved. Keep adding sugar, keep adding sugar. Add a little bit of flavor, add a little bit of color. Mix, mix, mix until it can't hold anymore. Woo, it is saturated at that temperature. And then you turn off the fire and you let it cool very slowly. When it gets to room temperature, it's now holding more than it should at room temperature. Okay, because it's super saturated. Okay, so what you end up doing is this. To make that rock candy on a stick, you heat the water up to boiling, put all the sugar that you can in it, mix, 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 all the flavoring, all the coloring, mix, 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 mix. And as you start letting the temperature come down, you put the sticks inside. And so what happens is the slower it cools, the bigger crystals of sugar that grab on to that stick, and it's captured the color and the flavoring. And then you have rock candy on a stick. Now you may remember to elementary school when you first were doing science, you maybe even had a teacher that y'all made crystals in class. And a lot of times they take a little bit of cup and you're going to mix something together and you didn't know what it was, but you're going to mix it up with water really, really good, pour more, mix, 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 and then you put a pencil across the top of it with a string or a piece of yarn. And then you let it sit there for a few days, maybe over the weekend or 4 or 5 days, and also when you pick the stick up, the string is full of crystals. Those are all the extra molecules that won't fit in the liquid. And so they form onto that string or onto that yarn or onto the stick if it's rock candy on a stick, and that's how it's made. It's super saturated. Here's what super saturated looks like in this example. Watch carefully. And I'm going to pause it real quick so you can see. I have to explain because it looks really weird when it happens. This time, what was it in the last one? 62.5 grams. Now it's got 175 grams. So they've heated it up to boiling. It's got way more than it should at room temperature. And what's going to happen, and I'm going to show it to you twice, is this. When they let it come back to room temperature, it's holding too much. And so what they do is they take a little crystal, they bump the jar, or they drop a crystal, just a single crystal of that sodium acetate trihydrate, and all of a sudden it crystallizes. Watch, there it goes. Looking at the top. It almost looks like it's freezing, but it's not freezing. It's crystallizing. And as it's crystallizing, it's going to literally take all of that extra and it's going to solidify. So it's going to become hard on top. It's all of the extra that shouldn't be there that came back out. So I'm going to give you a second to write down that example. Okay, write down that definition real quick. I'm going to show you an example on screen here in a second. Supersaturated solution holds more solute than expected at a given temperature and pressure. And that's the example right there. Okay? Now, what I have in my hand, I'm showing it up close to the screen, is called a hot pack. It's a reusable hot pack. And you will see, I'm going to show you through the back of it, it looks just like the inside of that beaker. I want you to look right here. See that little silver thing? It looks like a coin, but it's not. Okay, so what happens is, I can use this over and over and over. You put this in boiling water, and the trainers use this. Okay, for athletes, people can have it at their house. It's a reusable hot pack. Okay, so what happens is I put it into boiling water. When I put it into boiling water, all of this, it's hard. It all dissolves and it becomes liquid inside. When it becomes liquid, what I want to do is, see that little disc right there? I take it and I will push through the plastic and I'll pop that disc. Now, remember when you were a kid, you used to have, you know what a bouncy ball is. You remember those super balls where you bounce them and shoo, they would take off and you'd never find them again? Okay? You also found at those stores half a bouncy ball. When it was cut in half and it was hollow, and you would turn it inside out and sit on the table and it would pop up off the table. Okay? Maybe some of you remember that. That's how that disc is made. That little disc right there is concave. It's almost like a contact lens. And so when it's a liquid, all I do is pop it, and as soon as I pop that disc, it starts to crystallize. And when it starts to crystallize and become hard, it gives off heat. So if I'd hurt my neck doing something, when I pop that, it stays warm for a while. And when then it stops working, I put it back in boiling water, which means all these crystals will go back into liquid form. I can pop that disc again. When I pop that disc and it starts to crystallize, when it starts to crystallize, it gives off heat again, and I can use it over and over and over and over and over. Okay? Now, you may be seeing a reusable hot pack, or maybe you've seen a reusable cold pack. They do it in both. It's a chemical reaction. Some cold packs work like your glow-in-the-dark necklaces. You know those glow-in-the-dark necklaces? And when you take them, they're real long and straight, and you pop it's glass on the inside. Pop, 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 pop. You hear the glass? That mixes the two chemicals. You shake it up really good, put it around your neck, and it glows purple or yellow or orange or whatever the case may be. Okay? That's a chemical reaction. Will it last forever? No. Can you make it go back and start over and do it again? No. So as soon as that reaction happens, it gives off light and color. This is different. This is reusable. Okay? So I can put it back in boiling water, make all that dissolve back into liquid, and then I can pop that disc and all of a sudden it starts to crystallize. Now I'll show you the video again. I do it twice on here. Here's that supersaturated solution again. Watch, it's all dissolved in there, and they drop a single crystal, and all of a sudden it all starts to crystallize. And as it crystallizes, it solidifies. And so showing you the one that's in my hand is going to look just like that. Now, I don't know that reaction very well. I could probably grab the beaker. It might be hot. It might be cold, but it crystallizes. Why? Because the definition says right there, the solution is holding more than expected. It's holding more than it should. How did I do that? I heated up the solvent. You remember that word? That's the liquid part. Most times it's the solvent. It's usually water. I heat up the solvent, put in all the solute that I can. So let's do this real quick. Sodium acetate trihydrate and water. Which one's the solvent? Water's the solvent. The solute is the thing dissolving in. So this right here is the solute. So it says solution holds more solute, it holds more of this than expected in that water. And so I get it to do work for me. It's called saturation. Unsaturated means it could hold more. Saturated means it's full. Supersaturated means it's holding more than it should, And when you have a process take place, all of those extra molecules crystallize out. That is the term saturated. So make sure you watch the video. If you need to again, make sure you know these words. Guaranteed you'll see them on the next test. You're doing a great job. Keep up the good work.